Okay, welcome to Chapter 6 on decision trees. Hopefully this will start seeming familiar. Chapters 4, 5, and 6 were all on different types of machine learning models, and we are going to use the same basic structure for each one looking at the IRIS database. So Chapter 4 was on linear and logistics regression. Chapter 5 was on support vector machines, and 6 is on decision trees. And I think, again, a lot of this material you've seen before in some way, but again, we're looking at more from a machine learning perspective and how we set it up in our notebooks here. So again, a little introduction to decision trees here, and then our iris database, which we're familiar with our three types of iris flowers. And then again, we have this section 0. Again, our notebooks are structured with these different sections. But again, in this one is relatively simple. I think we just have these two sections in it. So section 0, we're going to input these our standard kind of set of libraries. So I'll just mention these. We haven't talked too much on. There's a library called Pandas and NumPy. These are really common methods for processing data in table format. And different ways of that, things like that. So a lot of work in Python, especially with data, is done with the Pandas library or the NumPy library. Seaborn or Matplotlib are both graphing libraries we use at times, and so they're always in here. And then the scikit learning library is a setup for machine learning, and that gives us all of our functions like our method for training and testing the data, and for scaling the data. And the scaling and the pipelines. And again, they also have models for decision trees, support vector machines, linear regressions, and things like that. For that. So we included all these. I like to have a lot of my includes at the top of my notebook here, although at some points you'll see them included. Some people like to include them later on, and I'll point that out. So like sometimes later on when we go through some code here, there'll be a import here for this. And so sometimes I'll comment that out because, again, if I have it included above, you don't necessarily need it here. So you just have to include it somewhere or the other. And my preference is to include them all at the beginning of the notebook here. Okay. So now we're going to input our libraries again, and so we're just reading in our data again. I'm just hitting some shift enters to run this code. And here's our flowers. Here's our first 5 flowers. And again, the length of the sepals, width, petal length, petal width, and then the species. And then there's 3 different species, and that's what we're trying to classify for this data. And again, we're going to break this up into our training and testing data. So we'll have X training, X testing as our inputs, and then Y training and Y testing as our the types of the species of iris that we're going to actually try to predict. So that code's all the same. Now we're going to talk about decision trees. And again, what the decision tree is going to do is try to look through this and try to come up with a whole bunch of if-then kind of like statements to break things up. So it's going to ask, like, if the petal length is less than 2.5, then you know it's this type of flower. Otherwise, you're going to see if the petal width is less than 1.75, and if it is, you go here, and if it's not, you go here. And now you ask another question, and then ask me. And so you're checking petal length, petal width, sepal length, and stuff like that. And so we create this tree, and then each of the leaf nodes is a prediction of one class or the other. And the idea is we don't have to necessarily create this tree manually. In the old days, we used to have to do this, but our model can look through all the samples and create a tree like this, right? So again, hopefully you've seen these before. So here's our setup for this. So let's just run this code. And again, we're creating a decision tree classifier here, and then we're fitting it with our data, our training data, and our labels, our training labels for the results. And then once we have that, we're going to run our test data for that and score it. And then this will tell us of the test data of the 20% of the flowers we reserved out for testing, how many we got correctly, and here we're getting 96% of them correct for that. So let's look at our textbook about this is decision trees, talking about those, and it does some work training. So again, this is very similar to the code we had. It's loading the data in. The textbook doesn't like to use the score method or breaking it up yet, and so they just have X and Y, but I like to introduce the testing and the training data at this point. So our code, our inputs and outputs are a little more complicated, but again, they're fitting the training here, and then they're trying to visualize that, and again, drawing these sorts of graphs. They're making a prediction. So if you have a flower of certain width, how do you make a prediction? Again, we're not going to worry too much about that, but basically what they're doing is they're dividing, if this is our flowers drawn in two dimensions, the first decision's here. If our petal length is less than this, then we know it's this type of flower, and then we go over here, and if a petal length is here, then we ask more questions about another parameter as we go. So, and again, a lot of this derivations and this probability stuff we're going to skip over. We're just not going to deal with this. Again, computational stuff, we're not going to worry too much about this. And this Gini parameter and entropy, I'm just not going to go into this. We're just going to look at it from a machine learning parameter point of view for this. And again, this talks about how to set some of these hyperparameters so it gets all of the different outliers or not that we're working with. So, and then you can also use this for regression. We're using it again for classification, so we're trying to predict one of 3 distinct classes, but you can also try to use it to predict a numeric value with regression. And again, I don't think it's the best choice for that, but we're not going to worry about the regression. We're just going to do the classification part of this. So. Okay, so again, we're not going to do too much in this, just give you an idea of how this works. There's some nice documentation at the sklearn documentation about the 2 parameters we often set, min sample and max depth. And so here, oops, I double clicked on that to edit it. Okay, the min sample here, the minimum number of leaves and the maximum depth of our tree that you can set in different ways. So, but what I want you to do now is just do a little bit of research and write up is, we've looked at these smart vector machines and decision trees, and try to do a little Google search or Google Scholar search or something like that, and try to see if you can find some comparison of that and give me 2 reasons for selecting one model or the other. When you're doing data, when would you use one? Is one faster? Does one work better with larger data sets? See if you can do some research into that stuff. So again, just a quick overview of decision trees in this version.